Section 10.4 Attractive Forces in Compounds. Now we'll look at the attractive forces that hold molecules and ions close together in liquids and solids. A solid melts and a liquid boils when the quantity of heat added is enough to disrupt the attractive forces between the particles. When the attractive forces in a substance are weak, it has a relatively low melting and boiling points. When the attractive forces are strong, the substance has relatively high melting and boiling points. Such differences in properties are explained by looking at the various kinds of attractive forces between particles, including dipole-dipole attractions, hydrogen bonding, and dispersion forces. Dipole-dipole attractions. All polar molecules are attached to each other by dipole-dipole attractions. Because polar molecules have dipoles, the positively charged end of the dipole in one molecule is attracted to the negatively charged end of the dipole in the other molecule. For example, the polar molecules of HCl form an attraction between the partially positive hydrogen atom of one HCl molecule and the partially negative chlorine atom in another HCl molecule. Hydrogen bonds. Polar molecules containing hydrogen atoms bonded to highly electronegative atoms, fluorine, oxygen, or nitrogen, form especially strong dipole-dipole attractions. These attractions, called hydrogen bonds, occur between the partially positive hydrogen atom in one molecule and the partially negative nitrogen, oxygen, or fluorine atoms in the other. Hydrogen bonds are the strongest type of attractive bonds between polar covalent molecules, but they're weaker than covalent or ionic bonds. They are a major factor in the formation of structural or biological molecules, such as proteins and DNA. Dispersion forces. Very weak attractive forces called dispersion forces are the only attractions that occur between nonpolar molecules. Usually, the electrons in a nonpolar covalent molecule are distributed symmetrically. However, the movement of the electrons may place more electrons at one end of a molecule than another, forming a temporary dipole. These momentary dipoles is what is normally a nonpolar substance align the molecules so that the positive end of one molecule is attracted to the negative end of the other molecule. Although dispersion forces are very weak, they make it possible for nonmolar molecules to form liquids and solids. Nonpolar molecules have weak attractions when they form temporary dipoles. The various types of attractions within ionic and molecular compounds and between particles in solids and liquids are summarized in Table 10.6. Comparison of bonding and attractive forces. Between atoms and ions, the ionic bond is very strong. Covalent bond between nonmetals is strong but not as strong as ionic. Between molecules, hydrogen bonding is the strongest, where the hydrogen will attach to either a nitrogen, an oxygen, or a fluorine atom. Temporarily. A dipole-dipole attraction is weaker than a hydrogen bond, and it is between an electronegative, something very electronegative one end and something not so electronegative on the other end. And the weakest of all the bonds are the dispersion forces, which is temporary shift of electrons in a nonpolar bond, which forms a temporary dipole and an attraction. Size, mass, and boiling points. As the size and mass of similar types of molecular compounds increase, there are more electrons that produce stronger temporary dipoles. In general, larger nonpolar molecules with increased molar masses also have higher boiling points. As the molar mass of similar compounds increase, the dispersion forces also increase due to the increase in the number of electrons. We tend to see the boiling points of the first four alkanes shown in Table 10.7. Methane has a boiling point of negative 162 Celsius. Ethane has a boiling point of negative 89 Celsius, propane negative 42 Celsius, and butane at negative 1 Celsius. Attractive forces and melting points. The melting point of a substance is related to the strength of the attractive forces between the particles. A compound with weak attractive forces, such as dispersion forces, has a low melting point because only a small amount of energy is needed to separate the molecules of the liquid and of the solid and form a liquid. A compound with dipole-dipole attractions requires more energy to break the attractive bonds that hold the particles together. A compound that can form hydrogen bonds requires even more energy to overcome the attractive forces that exist between its molecules. The highest melting points are seen with the ionic compounds that have very strong attractions between positive and negative ions. Large amounts of energy are needed to overcome the strong attractive forces between positive and negative ions and to melt the ionic solid. For example, the ionic solid sodium chloride melts at 801 degrees Celsius. Table 10.8 compares the melting points of some substances that have various kinds of attractive forces.